Hello everyone, you are all welcome to lecture number 1242, and today's lecture is in continuation of Pyrrole chemistry, and here I am going to discuss some of the important reactions of Pyrrole and its structure means acid base character or behavior of Pyrrole. Pyrrole is having lot of very good reactions with different alkali because it behaves as acid. The reason is that the two lone pair of electron on nitrogen like this. If you go to Pyrrole, the situation is like this. Here, these two electron which is available here on nitrogen is playing very important role. Its first role is that it is becoming the part of pi electron of this 5-member ring, and that's why it gives aromatic character, and it is very strong aromatic in character, even more than benzene, and also it is flat molecule. So these two electrons are easily available to combine with any alkali like potassium hydroxide. Potassium salt will be formed. So it is having acidic behavior or acidic character because of easily availability of the electron on this nitrogen, and this one is a very weak base. The reason is that it is involved in this, this electron is easily available, and here for its basic character, this molecule is not proper to accept the proton. Protonation is very difficult. So since protonation is very difficult, because that those two lone pair of electrons, they are easily available, that is the reason that Pyrrole is weak base. And also, when we are talking of structure, orbital picture of the Pyrrole, it is having a sextet electron cloud moving around the 4 carbon atoms and giving it the resonating structure. So that orbital picture I will give you. Here there are some important reactions of Pyrrole with different chemicals, and in this reaction you can notice that it is mostly electrophilic substitution reaction, and all those electrophiles are substituted, or sometimes nucleophile in the place of that either nitrogen or any carbon, that is 4 carbons are available by replacing hydrogen. So it is mainly substitution reaction. That's why it is aromatic character, and it is not 2 double bond inside the 5-member ring, rather than they are delocalized, and that's why it is not pure double bond rather than a resonating structure, and because of that it is aromatic in character and undergoes substitution reaction rather than addition reaction. Number 1, when Pyrrole treated with hydrogen, Pyrrole substitutes slowly to form tetra substituted derivative, and in presence of sodium or potassium hydroxide and the very important product that is called iodole. So here it is Pyrrole, and Pyrrole is treated with 4 molecules of iodine in presence of 4 molecules of potassium hydroxide, and these 4 carbons are substituted by iodine, and you are getting that is iododerivative of pyrrole, that is called iodole. And number 2, like phenol, pyrrole undergoes Reimer Tiemann reaction, is a rearrangement reaction, name reaction, and in this reaction it gives pyrrole to carboxylic acid, because at 2 position the carboxylic group is substituted, and this reaction is possible in presence of 3 molecules of sodium hydroxide. So you see these reactions here, all these reactions are showing very clear picture of acidic character. It is behaving as an acid, that's why with base it is reacting. Number 3, potassium pyrrole absorbs the molecule of carbon dioxide under pressure, and it is again converted into pyrrole 2 carboxylic acid. So this is potassium pyrrole, it is called potassium salt of pyrrole molecule with carbon dioxide under pressure. It is converted into pyrrole 2 carboxylic acid. So here I am going to discuss the acid and basic character of pyrrole compound, and I have already told you that pyrrole is very weak base. The reason is that the electron which is sitting over nitrogen, that is called lone pair of electron, is not available for protonation, but that same electron which is the part of delocalization of pi electrons in the ring forming sextet is very easily available for combination with any alkali. So since the electrons are very easily available, that gives the very strong acidic character. It is a very special type of unique behavior of pyrrole, that in spite of the fact that nitrogen is there as a part of a ring, it is aromatic in character and it undergoes substitution rather than addition, and is acidic, strong acidic, not basic, and it is very weak base. So here I have given how the resonating pi electron is showing. So here it is pyrrole compound, and in this pyrrole you can see that two electrons, two lone pair of electrons are sitting over nitrogen, and it is becoming the part of sextet, and that's why with potassium hydroxide very easily it is combining and forming the salt, because these two electrons are very easily available with this potassium ion, and here when hydrogen is going, there will be formation of minus here, because H positive will be out substituted by K positive, and this minus is resonating to each carbon. This is resonating structure, this is the first, then second resonating structure, then third resonating structure, and it is fourth. So in this way it is having 4 resonating structure where this minus charge will be delocalized. Acid character of pyrrole is due to easily release of electron, very easily that electron which is available here is easily released of the electron on nitrogen atom, and which is involved more in the formation of sextet. Sextet means 2 plus 2 plus 2. So it will become 6. 2 electron, if I put like this, in place of this 2, and then it is 2, so it will become 6. Pi electron is called sextet, and its resonating will be like this. And because of formation of sextet, which is responsible of giving aromatic character to pyrrole ring. And also now discuss the basic character. The lone pair of electron on nitrogen atom of the pyrrole ring system is not available for protonation. So once protonation is not done in presence of this lone pair electron, that is clearly indicates the reason of becoming very weak base, because protonation is not easily possible. Number 2 here condition, I have given the orbital picture of pyrrole. So here the delocalized pi electron cloud is shown here, and there are 4 carbon atoms with 1 nitrogen. These 4 carbon, 1 nitrogen, their orbital picture, it is sp2 hybridized, it is flat molecule, and also the contain unpaired pi electrons, and that pi electron is in the form of electronic cloud. So with this I will stop. Thank you very much for watching the lecture.